Good day everyone! Welcome again to my video tutorial. So for today's video, we will talk about the transportation problem in linear programming. So before anything else, I'm Sergeant A. Arwata from BSED Math 2A in Kapalong College of Agriculture Sciences and Technology or KCAST. So transportation problem. Transportation problem is a special type of linear programming problem where the objective consists in minimizing transportation cost of a given commodity from a number of sources or origins to a number of destinations. So for example, in Asunción area, there are 3 poultry farms under the management of Vitarich Company. Every month, they will harvest and sell it in 3 different markets in Davao City, Market 1, 2, and 3. The poultry farm's supply of broiler chicken, demand of 3 markets, and cost of transporting 1 bags of chicken from each poultry farm to each market are shown below. So this is the table of the problem from the source, which is the poultry farm 1, 2, and 3, to the destination, which is the market 1, 2, and 3, that has a supply and demand. And the problem is to determine how many bags of chicken to transport from each poultry farm to each market to minimize the total cost of transportation. So, the first thing we must do is we will calculate the total supply of supplier and the demand. The total supply of supplier must be equal to the needs of consumer. And then, if equals, we can proceed to the 3 method. We have the supply of 200 plus 300 plus 500 is equal to 1,000. Our demand is 400 plus 500 plus 100 is equal to 1,000. Since it is equal, so we can proceed to the 3 method. But before we proceed to the 3 method, we will let U as our source, which is the poultry farm 1, 2, and 3. And then let V as our destination, which is the market 1, 2, and 3. And now we will proceed to the first method, which is the northwest corner method. In northwest corner method, we will start in U1, V1 in our first cell in our constraints. So the U1, V1 have the demand of 400 and have the supply of 200. And the minimum of 400 and 200 is equal to 200. Since 200 is the minimum, so 200 is our value of our U1 and V1. After that, since in demand of column 1 have a 400, so 400 subtract the 200 is equal to 200. So the demand reduced and became 200. The demand of our market 1 is now 200. And then the supply of our poultry farm 1 have 200, so 200 subtract to 200 is equal to 0. Since our row 1, which is our poultry farm 1, is 0 in our supply, so the rest in row 1 is 0. Now we will proceed to the step 2. In step 2, since we have the demand of 200 in our column 1, so we will still in column 1, which is the U2 and V1. We will proceed to the row 2 since our row 1 is 0. So in row 2, we have the U2 and V1. The demand of U2 and V1 are 200 and the supply is 300. Then find again the minimum of 200 and 300 is equal to 200. Since the minimum is 200, so the value of U2 V1 is equal to 200. After that is the demand is, since we have the demand of 200, subtract the 200 is equal to 0, and then the supply 300 minus or subtract the 200 is equal to 100. Since the demand is 0, so the rest in column 1 is 0, which is the U3 V1 is 0. And then the third step is we'll proceed in column 2, but still in row 2 since we have still 100 in our supply. And then again the minimum of the 500, which is the demand, and the 100, which is supply, is equal to 100. So the minimum, which is 100, we will put that as a value of our U2 V2. And then since we have the demand of 500, so 500 minus or subtract into the 100, which is the value of our U2 V2, is equal to 400. And then our supply, which is 100 minus 100, is equal to 0. Since the supply of row 2 is 0, so the rest in row 2 is 0, which is the U2 V3 is 0. Then the next step is, since we have still the demand in column 2, we have 400, so we will still in column 2, and then we will proceed in row 3, which is the U3 V2, and then we will proceed to the minimum since we have the demand of 400 and the supply of 500. So the minimum of that is 400. So we will put the value of U3 V2 is equal to 400. And then the demand is 400 minus 400. So our demand now is 0 in column 2. And the value of our supply now in row 3 is 500 minus 400 is equal to 100. And then in the next step is, since the demand of our column 2 is 0, so we will proceed to the column 3. And then still in row 3, since we have supply in row 3 of 100 and the demand of column 3 of 100, so the minimum of that is 100. So 100 minus 100 is equal to 0 in column 3 and row 3. So as we observe, our demand and supply are now equal to 0. After that is we will calculate the total cost of delivery, which is the 200 times 70 plus 200 times 60 plus 100 times 50 plus 400 times 60 plus 100 times 20 is equal to 57,000. After the northwest corner method, we will proceed to the least cost method, the second method. So in least cost method is, since this is our constraints, we will find the least value. Since the least value is the 20, which is the U2 V3 and U3 V3. Since there are two least values, so it's up to you where you want to start. If you want to start in U2 V3 or you want to start in U3 V3. And me, I want to start in U2 V3. So I will start in U2 V3. So I will find the minimum of 100, which is the demand, and the supply is 300. So the minimum of 100 and 300 is 100. So I will put the minimum value in U2 V3, which is 100. And then the demand of 100 minus 100 is equal to 0, and then supply is 300 minus 100 is equal to 200. Since the demand of our column 3 is 0, so the rest in column 3 will become to 0. And then after that is find again another list. Since the list is 50, there are two 50, which is in U2 V2 and U3 V1. Again, it's up to you where you want to start. So I want to start in U2 V2. So I will find again the demand of U2 V2, which is 500, and the supply is 200. So the minimum of 500 and 200 is 200. So I will put that as a value of our U2 V2. And then the 500 of demand minus 200 is equal to 300. So we will have it 300 now in our demand in our column 2, and then the supply, which is 200 minus 200, is equal to 0. So the row 2, the supply of row 2 is 0. Another is find again the list. Since 50 again, so the demand of the U3 V1 is 400 and the supply is 500. Find again the minimum, which is the 400. So 400 is our value of our U3 V1. And then the demand is 400 minus 400 is equal to 0. And then the supply is 500 minus 400 is equal to 100. Since the demand of our column 1 is 0, so the rest in column 1, which is U1 V1 and U2 V1, is the value of 0. And then find again the list. So there are two unoccupied cells, which is the 80 at saka 60. Since the list is 60, so I will start in U3 V2. So in U3 V2, the demand is 300 and the supply is 100. And the minimum of that is 100. So I will put the value of U3 V2 of 100. Then the demand is 300 minus 100 is 200. So we have still 200 of demand in our column 2, and the supply is 100 minus 100 is equal to 0. So there are 1 cells that remain, which is the U1 V2. Then find the minimum of the, which is have the demand of 200 and the supply of 200. So the minimum is 200. So 200 of demand minus 200 is equal to 0, and the supply is 200 minus 200 is equal to 0. And now our demand and supply is equal to 0. So therefore, we can calculate the total cost of delivery, which is 200 times 80 plus 200 times 50 plus 100 times 20 plus 400 times 50 plus 100 times 60 is equal to 54,000. As we observe from the northwest corner method, which is 57,000 reduced in our least cost method, which is 54,000. And now we will proceed to the Vogel Approximation Method. So in Vogel Approximation Method is we will calculate the first is in the column 1, which in column 1 find the least value, which is the 50, and the second least is 60. So we will subtract it. 60 minus 50 is equal to 100. So we have the column penalty of column 1, the penalty is 10. In column 2, the penalty is, since the least is 50 and the second is 60, so 60 minus 50 is equal to 10. In the column 3 is, the least is 20 and there are two 20, so 20 minus 20 is equal to 0. So that is our column penalty, and now we proceed to the row penalty. In row penalty is the least is 30 and then the second least 70. So 70 minus 30 is equal to 40. And then in row 2, we have 50 minus 20 is equal to 30. And then in row 3 is 50 minus 20 is 30. After that is, in all penalty, find the highest value. Since the highest value of all penalty is 40 in row 1 rather, so in row 1 we will find the least value of constraints. Since the least value of constraints in row 1 is 30, so in that cell we will find the value. So since the demand of U1 V3 is 100 and the supply is 200, so the minimum of 100 and 200 is 100. So 100 is the value of our U1 V3. And then the demand is 100, so 100 minus 100 is equal to 0. And the supply is 200 minus 100 is equal to 100. After that, since our demand is 0 in column 3, so the rest in column 3 became to 0. And then after that, proceed again. The penalty of column 1 is, since the list is 50, so 60 minus 50 is 10. In column 2 is 60 minus 50 again, 10. In column 3, so there's no na, since the demand is 0. In row 1 is 80 minus 70, since the 30 is not included since it is the occupied cells na. So 80 minus 70 is equal to 10. In row 2 rather, is 60 minus 50 is equal to 10. And then 60 minus 50 in row 3 is 10. So in all penalty is the same value of 10. So it's up to you where you want to start. Since I will choose the row 3. So in row 3, I will find the list again. So the list is 50 since 20 is not included. So the choices is 50 and 60. So the lowest is 50. So I will find the value of U3V1. And then the demand is 400 and the supply is 500. So the minimum of that is 400. So the value of U3V1 is equal to 400. And then the demand is 400 minus 400 is equal to 0. And the supply is 500 minus 400 is equal to 100. Since the demand in column 1 is 0, so the rest in column 1 is become to 0. The next step is, since the column 1 is 0, so it is not included. So in column 2, so the list is 60 minus 50 is equal to 10. So we have 10 penalty in column 2. In column 3 is not included since the demand is 0. In row 1, the penalty is 80 since 70 and 30 is not included. So since the only choice is 80. In row 2, there are 50. In row 3 and is 60. So in that row and column penalty, the highest value is 80. So I will find the value of U1V2. Since the demand of U1V2 is 500 rather, and the supply of U1V2 is 100, so the minimum of 500 and 100 is 100. So I will put the value of U1V2 is equal to 100, then the supply will become 0, and the demand is 500 minus 100 is equal to 400. So there is still demand in column 2, which is 400. So find again the penalty and then find the highest. Since the highest is 60, so I will find the value of U3V2. And then the U3V2 has the demand of 400 and the supply is 100. The minimum of 400 and 100 is 100. So I will put the value of U3V2 is equal to 100. Then 400 of demand minus 100 is equal to 300. And the supply is 100 minus 100 is equal to 0. So after that, there are only one cells. So we will proceed that since U2V2 have the demand of 300 and the supply of 300. So we have 0 and 0 in our supply. So the demand and supply is all 0. And now calculate the total cost of delivery. So 100 times 80 plus 100 times 30 plus 300 times 50 plus 400 times 50 plus 100 times 60, which is the total cost of 52,000. And as we observe, the Northwest Corn method have the 57,000, the total cost of 57,000, and the least cost method is 54,000, and the Vogel Approximation Method is 52,000. And since the total cost of Vogel Approximation Method or VAM or VAM is the lowest, then I will use this method to proceed the Moody method or UV method. In Moody method or UV method, first is calculate the Rhodes use, which is the formula of Cij is equal to Ui plus Vj. And let V2 is equal to 0. I will let V2 is equal to 0 since the V2 or the column 2 has the most occupied cells. That's why I will let V2 is equal to 0. Now, we will proceed to the occupied cells, which is the U1 V2 is equal to 80. So U1 plus V2 is equal to 80. Then since we have the value of V2, so we will find the U1. So U1 is equal to 80 minus V2 is equal to 80 minus 0 as our value of our V2 is equal to 80. And then in U2, V2 is equal to 50. So since there are value of V2 again, so we will find the U2. So U2 is equal to 50 minus V2, which is 0, is equal to 50. And then we will proceed to the U3 V2, which is 60. So since there are the value of V2, which is 0, so we will find the U3. So U3 is equal to 60 minus V2, which is 0, is equal to 60. And then we'll proceed to the U1 V3, which is equal to 30. Since we have the value of U1, which is 80, so we will find the V3. So V3 is equal to 30 minus the value of our U1, which is 80, is equal to negative 50. And then lastly is the U3 V1 is equal to 50. Since we have the value of U3, we will find the V1. So V1 is equal to 50 minus U3, which is 60, is equal to negative 10. After that, we will put the value, since we have the U1 is equal to 80, U2 we have 50, U3 is 60, we have the V3 is equal to negative 50, the V1 is negative 10, and our V2 is equal to 0. We can proceed to the unused rows. So in unused rows, we have the formula of Cij minus cost of delivery. In U1 V1 is equal to 70, which is the value of U1 V1, 70 minus the cost of delivery. So the cost of delivery is 80 in U1 plus negative 10 in V1. So 70 minus 80 plus negative 10 is equal to 0. Now we will proceed to the U2 V1, which is the value of 60 minus the U2, which is 50, plus the V1 is negative 10, is equal to 20. In U2 V3, so we have 20 minus the value of U2 is 50 plus the value of V3 is negative 50 is equal to 20. And lastly is the U3 V3, which is the value of 20 minus the value of U3, which is 60, plus the value of V3 is negative 50 is equal to 10. And since the Dij or the unused rows are all positive, therefore it is not possible to reduce the total cost. And we will not proceed to the looping, since the looping can be used only if the Dij or the unused rows have a negative. Since the value of our unused rows are all positive, so the final optimal solution is arrived. And therefore, we can conclude that in poultry farm 1, we can only deliver 100 bags in market 2 and 100 bags in market 3. And in poultry farm 2, we can only deliver 300 bags only in market 2, 300 bags in market 2. And in poultry farm 3, we can deliver 400 bags in market 1 and 100 bags in market 2, so that the minimum of total cost is 52,000. So that's how you should calculate in every transportation problem. And that's all for today's video. I hope you will learn from me, and thank you for watching.